Hello, geometry. So, today we are going to fill out everything about all the parallelograms. So we're going to look at what, I don't know what that was I just said. So we're going to look at rhombuses. So what is a rhombus? It has four congruent sides and it is a parallelogram. We are going to look at rectangles. So rectangles have four congruent angles, which means that they're all 90 degrees. It too is a parallelogram. And we are going to look at squares, which I call the garbage can of all the parallelograms, because a square has both four congruent sides and four congruent angles. It is also a parallelogram. So we're going to get into all the properties of those and kind of fill out our flow chart for parallelograms. So this first corollary, I can talk, says if a just regular quadrilateral, doesn't even say parallelogram, if it's a quadrilateral and it has four congruent sides, we know it's a rhombus. So looks kind of like a diamond. There you go. Four congruent sides. So the angles are going to be just like a parallelogram. Opposite angles are still congruent. So rectangles, if a quadrilateral has four congruent angles, which since they have to add up to 360 means they're all going to equal 90 degrees, then it's a rectangle. Rectangle. All right, so here is your rectangle. So our first example here, given RSTU, so we're looking at this shape over here, is a rectangle. STR, this angle right here is 8x plus 3. UTR, this angle right here is 16x minus 9. So we know that those two angles together have to add up to 90. So we're just going to set up our equation. We know this has to equal 90 degrees, those two angles. So what do I have? 24 x's, 8 and 16. 3 minus 9, negative 6. So 24x equals 96, adding 6 to both sides. So x is going to equal 4. But the question was, what's the measure of STR? So we plug 4 back in over here. 8 times 4 plus 3 means that angle STR is going to be 32 plus 3, which is 35 degrees. So that would be our answer. All right. Then we have our square corollary. So if you have a quadrilateral with four congruent sides and four congruent angles, then we know it is a square. Because a square is both a rhombus, it's an equiangular rhombus, and an equilateral rectangle. All right, so what we have here is a depiction, a Venn diagram is what this is called. So this is a Venn diagram that kind of shows the interlap of everything. But what I'm going to do is remind you, so we have parallelograms. And so what we came up with here is the definition said we had opposite sides are parallel. Then we had some properties. We knew that the opposite angles are congruent. We know that the opposite sides are congruent. We know that the diagonals bisect each other. Bisect each other. And then you had the consecutive angles. Remember, consecutive angles were supplementary. So because your rectangles come under that and your rhombi come under that, they too, and then you have your squares, because the way a flowchart works, rectangles, rhombi, and square have all the properties of a parallelogram. They just have some extra properties on top of it. For instance, the rectangle is 4 congruent angles, the rhombi is 4 congruent sides, and like I said, the square is the garbage pail of everything, because the flowchart, everything flows into squares. It has everything that came before. All right, so let's look at this. These sometimes, always, never can be difficult. So you want to really try and think, can you come up with a counter example? So a square, is it always, sometimes, or never a rectangle? Since the square comes after the rectangle and has all the properties of a rectangle, a square is always a rectangle. A rhombus, does it always, sometimes, or never have 4 congruent angles? Here, what I would say is sometimes, because if the rhombus is a square, then that would be true. All right, because they're next to each other, but rhombi, remember, a square is also a rhombi. So if your rhombus happens to be a square, then it will have 4 congruent angles. A rectangle, does it sometimes, always, never have 4 congruent sides? Well, that's kind of like the last question. If the rectangle is a square, then that would be true. So this is only true when your rectangle also happens to be a square. So that's why we say sometimes, not always. And then a parallelogram, always, sometimes, never have diagonals that bisect each other. And this is a straight up always. Okay? Now, use the following biconditionals to prove that a parallelogram is a rhombus or a rectangle. I don't see the... Oh, I see. We're going to turn this into rhombus diagonals theorem. All right, so here's another property of diagonals, or for rhombi. So you have a rhombus over here. So we know rhombus is parallelogram with all 4 sides are going to be congruent. And because the sides are the same length, when you draw the diagonals, they aren't going to be congruent, but they are going to be perpendicular. So the way we would write this is a quadrilateral is a rhombus if and only if, so remember we abbreviate that way, that means I can read this both ways, the diagonals are perpendicular. So they meet at a 90-degree angle. You have right angles, which means you have 4 right triangles. So yeah, right triangles are going to play a big part as we move forward. So if all your diagonals are perpendicular, you know you have a rhombus. If you have a rhombus, you know the diagonals are perpendicular. So it works both ways. And then we also have some more properties for rhombus. And because, again, a square is a rhombus, a square also has perpendicular diagonals. So another special property of your rhombus is that the diagonals will bisect the opposite angles. Remember, opposite angles are congruent in a parallelogram, but in a rhombus, because the sides are congruent, we should keep emphasizing that, they bisect opposite angles. So these 2 are congruent and those 2 are congruent. So to write this as a biconditional, I'll write it in the opposite way this time. Diagonals bisect opposite angles if and only if the quadrilateral is a rhombus, which means this is true in a square as well. Okay, Okay, diagonals bisect opposite angles if and only if your quad is a rhombus. If it's a rhombus, the diagonals bisect the opposite angles. All right, so let's apply this property. So down below here, given rhombus ABCD, find the measure of all the numbered angles. So right off the bat, we know angle 1, and again, you might want to pause the video and try this on your own, and then start it up to see if you got it right. We know that angle 1 is 90 degrees because diagonals are perpendicular. We know that angle 2 and angle 3, they're going to be congruent because they are bisected, but they're also going to both be 61 degrees because these two angles would equal those two angles. So now I have a triangle, right triangle. Here was angle 3, which we said was 61 degrees, and we're trying to find angle 4. So angle 4 is going to be 90 minus 61, which is 29 degrees. Okay? Okay, now we're going to get our first quadratic. So we have a rhombus. Remember, rhombus, all the sides are congruent, your diagonals are perpendicular, opposite angles are bisected. Your diagonals are bisected as well, remember, because it is a parallelogram. So there's a lot of properties going on here. So given rhombus ABCD, angle BAC, this angle right here, is 2x plus 10. Angle BAD, the whole angle, is x squared minus 2x plus 4, and then they want us to find the measure of ABC. All right, interesting. Okay, so 2x plus 10 is only half of the angle. So I know that 2 times 2x plus 10 has to equal the measure of the whole angle that they told us is x squared minus 2x plus 4. So we're going to solve this for x. So this gives me 4x plus 20 when I distribute. And now we want to set this whole quadratic equal to 0. So I'm going to subtract 4x from both sides. So that gives me minus 6x. And I'm going to subtract 20. 4 minus 20 is a negative 16. So we have ourselves a quadratic that we want to factor. So I have a negative 16 here and a negative 6. Looking at factors of 16, how about a negative 8 plus 2? That would multiply to a negative 16, but add to a negative 6. So those are the numbers that go in my parenthesis, x plus 2. So I know that x equals 8, or x equals a negative 2 when I set each factor equal to 0. And so what we need to do now is find the measure that corresponds with each answer, because it will be different. So we have, if x is 8, and I'm trying to find the measure of ABC, this whole angle. All right. Well, I'm going to first find the measure of angle A, knowing that that measure of angle B over there is going to be the supplement. So if I plug in 8, I get 64 minus 16 plus 4, and that is going to be, oops, I have to get out my calculator. 64 minus 16 plus 4 is 52. So this angle here is 52. So 180 minus 52 is 128. So that's the answer if we use x is 8. If I use the answer x equals negative 2, then I'm plugging in negative 2 squared is 4, minus 2 times a negative 2, so that's plus 4 plus 4. Okay, well that makes that angle 12. And so then we get 180 minus 12 is 168. because we would be doing 180 minus 12. So remember, you still have all the properties of a parallelogram. So they didn't give me anything about measure of ABC. I had to use the measure of angle A, the whole angle, and then angle B is the supplement, because the consecutive angles are supplementary. All right, now we give you this huge space for a very simple concept. Because a rectangle has the 4 90-degree angles, so it's sitting up straight. And again, opposite sides are congruent, but all 4 sides are not congruent. What that does, by straightening it up, the diagonals are still bisected, but in a rectangle, you get an even stronger, the rectangles, I'm so silly, sorry, my brain just took a little vacation. The diagonals are congruent, which means you have 4, so that one equals that one equals that one equals that one, but diagonal AC is congruent to diagonal BD, the whole diagonals. So they are congruent, they are also bisected, since a rectangle is a parallelogram. But they are not perpendicular, only in the rhombus. Okay, so how do we apply this theorem? Given RSTU, US is the whole diagonal, and that is 6x plus 3. RT is a whole diagonal, and they're telling us that one is 7x minus 2. And since I know the diagonals are congruent, I can set these equal to each other, and we get x is 5, but remember, this is not algebra, this is geometry, so we have to give them what they want. They wanted UQ. So I know US equals 6 times 5 plus 3, which is 33, so that means that UQ is half of that. So I'm just going to say 33 halves. If you want to make a decimal, that's on you. All right, now this one is going to be, I'm going to talk a lot about shortcuts here. So we want to decide, after we plot this quadrilateral, is it a rectangle, a rhombus, or a square? And I'm going to talk about some shortcuts here, but let's first plot this. So A is at -2, 3. Here's A. B is at 2, 2. So here's B. 1, -2 is C, and D is at -3, -1. Now, I know that on the test, people are going to just look at the shape and they're going to make a decision. Unfortunately, we also look for your work. So there's a couple things I want to talk about. Your slope formula, which you will need from time to time, is this. And your distance formula basically takes your slope equations, right? So this would be x2 minus x1 plus, and over here, we would have y2 minus y1. So notice when you calculate your slope, you're also calculating the numbers you would use in your distance formula. So you don't have to do the same calculations twice. So what I like to do is I just like to find the slope of all 4 sides. So I'm going to have the slope of AB, the slope of BC, the slope of CD, and the slope of AD. So if I find these slopes, you can then very easily, quickly find the length. And again, slope, it's on a grid. You're welcome to do your the actual formula, or since it's on a grid from A to B, I know I can go down 1 and over 4, down 1 over 4. That tells me that the length of AB, notice I didn't put any line over it because that means length, is 1 squared, let's see, let me make this a little shorter, because it's going to be 1 squared plus 4 squared. You can drop any negatives, so that's going to be the square root of 17. Now let's go to BC. So BC, I go 1, 2, 3, down 4 over 1, down 4 over 1. So that tells me the length of BC is going to be, again, 4 squared plus 1 squared is square root of 17. Then we have the length of CD. So to get from D to C, I'd go down 1, back 4. So that tells me the length of CD, hopefully you're seeing a pattern here, is 4 squared plus 1 squared, square root of 17. And lastly, A to D, I would go 1, 2, 3, up 4 over 1. I did BC wrong. Sorry about that. B, I went down and down, so they were both negative, which means they both tend to then be positive. So that should be a negative there, which cancels each other out to be positive. So let me go back down to AD. Also, I went up and over, so that's going to be, I went up 4 over 1. So the length of AD, 4 squared plus 1 squared is, so from here, we know all 4 sides are congruent, so it's potentially a rhombus. I know that opposite sides are parallel, but even more importantly, adjacent sides. So if I look at adjacent sides, I get negative 1/4 versus 4 over 1. The product of those two would equal negative 1. So I know that the adjacent sides are perpendicular. So this is a quadrilateral with 4 congruent sides and 4 congruent angles. That tells me it's a square because I have all 4 sides and the consecutive sides are perpendicular. All right, so I strongly suggest you use that shortcut. When you calculate your slope, those are the same numbers that go into your distance formula, so you don't have to do the numbers again. Just don't simplify your slope when you go to calculate the distance. All right, have fun.